Building software from scratch is always a craft. If you don't use the constructs properly, you may end up burning a lot of extra hours in building and maintaining the software. Therefore, it is necessary to use the correct software design patterns. We often don't remember the design pattern because we construct most of the softwares using available frameworks and libraries, but we do not pay any heed to understand the underlying patterns being used by those frameworks and libraries. So therefore, it is very important and necessary for all the software developers to think about software design pattern. So in order to understand what software design pattern is, you have to understand what it is and it is not. So what it is a solution to a design problem, and it's a generalized way to tackle a recurring software problem. What it is not is algorithm, and it doesn't relate in any case with the actual code that you write in your function. Let's understand the types of software design patterns. So broadly, the software design patterns can be classified into three types. First is creational. Creational type of design patterns, they deal with the creation of the objects, because in object oriented programming we create objects using various classes, and creational type of design pattern is used to handle all that stuff, and it increases reusability of code. Following are the creational type of design pattern, and the highlighted ones we will talk about later in this video. Second type of software design patterns are structural design patterns. So now that we have created the objects in the system, it is time to arrange these objects in order to create a larger picture. So structural design patterns comes into the picture, and they further increase the efficiency of the. So available design pattern under structural umbrella are written here, and the facade type of structural pattern we will discuss in the code later. Third type of design pattern umbrella is behavioral design pattern. Now that we have created the objects and we have arranged the objects, it's time to communicate between these behavioral patterns. They focuses on the overall interaction between different objects in the system, and they further increase the maintainability of the system because they assign responsibilities to each of the objects involved in the overall structural design of the software. Let's discuss the design problem that we will show you in the code. So we are designing a smart home solution in our software problem. So first of all, we will start with the raw implementation design and start with certain devices and sensors that we will create, and it will grow based upon the user's requirement. Soon we will realize that the code is getting messy and there will be a large spaghetti code introduced in this raw design. So after noticing that, we will feel a need of adding design patterns into the system and optimize our code using many design patterns as an example. So let's go to Visual Studio Code in order to understand what we will talk about. So as an example, we have designed a very basic software for a smart home. A smart home can be visualized as a network of various devices and some sensors. As you can see, we have defined various device classes such as light, which can be turned on and off, thermostat that will be used to regulate and set the temperature, and a camera which can either be enabled or disabled. So in the raw implementation, what we have done is we have created the objects out of all these device classes. Secondly, we have defined a motion sensor. A motion sensor will be the class that will be responsible for detecting a motion, and on detecting the motion it will perform certain functions on the various devices. Let's suppose on detection of a motion we want the light to be turned on, the thermostat to be setting a temperature of 22 degrees centigrade, and the camera that will be enabled automatically. We now create the object for this motion sensor, so it can be used later on to call motion detection function. Next, we have written functions that will perform certain tasks. For example, we have defined the night mode activation function. So this function will activate the night mode. As we know that in the night there are no lights, so we will turn off the lights and the temperature goes down. We will decrease the temperature to 18 degrees centigrade and the camera is enabled for vigilance. Similarly, we will have a function called activate morning mode. So in this also we will turn on the light, set the temperature and disable the camera. And the raw simulation of all these available functions can be presented like this. We call the motion sensor object and triggers a function, and then we trigger these anonymous hard-coded functions like this. So given this code, we could easily visualize that this is not a extendable design, because you have vague set of codes, you have hard-coded use of objects in the system, and nothing is maintainable. And as it grow, as the number of devices and number of sensors increase, there will be a lot of confusion, there will be a lot of chaos, and the code becomes almost difficult, impossible to maintain. Let's think about optimizing this raw implementation and add design patterns to achieve refactoring. So as far as refactoring is concerned, what we have done here is we have created a device class which will act as a parent class for all the devices that we introduce in the system. So every device, as you can see, will extend the device class and it will perform its operations. We have also updated the thermostat device class. We have also updated the thermostat class to have a strategy pattern applied to it. As you can see, we have defined a default strategy for the thermostat. Think of thermostat to be operating on different type of modes. Let's assume that the eco mode will be the default mode, and we will set a strategy function that will automatically change the mode, which is strategy. And at any point of time in the software, we can apply that change and the strategy will be implementing the temperature change. Second thing to notice here is we have created a device factory in order to achieve factory pattern in our system design. So device factory is a class that has a create function. On the basis of type of the device, we can instantiate the device object. As you can see, when the device type is light, we will create a light object, light device object, and in case of camera or thermostat, we will create the respective object. Next is the strategy pattern. We have created a strategy interface that will implement a set temperature function, and in each of the modes that we have created as a strategy, we will define this function and we will set the temperature according to the mode. Now comes the command pattern. So command is nothing but the action of the devices. The action of the devices can be performed by any trigger, or it can be performed in the code as well. So by trigger, it means that when a sensor senses something and it has to execute a particular device function, so it will implement it as a call to the command. So we create certain commands. For example, light on command, light off command, camera enable command, camera disable command, and thermostat apply command. So these classes are self-explanatory, in which these commands are created by using a particular device, as you can see here. So that particular device will execute this command, and the actual command that will run will be the function on that particular device. In a smart home system, commands will be run through routines, because a single command is not likely to be run, and always we will run a set of commands only. So we will define a set of commands using builder pattern. So we will keep on adding the commands into a routine and we will execute that routine itself. So let us understand the builder pattern here. So we define a routine, and a routine can have a set of commands. So in order to build that routine, we have a builder class. So routine builder comes into the action and it can add a command to the routine incrementally. As you can see, we can chain the add command function to the routine builder and it can keep on adding the commands to the routine. So that's about builder pattern. So now comes the observer pattern. You can think of observer pattern as event driven and publish subscribe type of system. So imagine you have motion detector. So this is the most motion sensor and you want to detect the movement. As soon as you detect the movement, you want to notify several devices in the system, right? So those devices that are notified becomes the observers and the motion sensor, it becomes the publishers. So this motion sensor publishes the messages. That message or you can say event will be cached and acted upon by the observers that are listening to that. So the example is light observer. You want to turn on the lights, then camera, you want to enable the camera, or maybe you can send a notification to the phone, so that becomes an observer as well. In the motion sensor raw implementation, we were having all the objects hard coded here, but as you can see now the motion sensor is very elegant, and even if you add a lot of observers in the system, you need not to make any change in the implementation of the motion sensor. So that is how observer pattern is saving us. The facade pattern. So if we talk about facade pattern, it is an abstraction, or you can say adding a facade to the underlying complexity of all the subsystems that are involved. In this example of smart home software, so we are having certain subsystems. For example, we want to activate night mode. So activating a night mode is a complex operation, and it is an underlying subsystem in which many commands are involved, such as light should be turned on or off, temperature should be changed, and camera should be either enabled or disabled. So these kind of stuff is activating in the activate night mode and activate morning mode functions. So facade actually it hides all those complexities before a facade. So what you will do is you will create the instance of the facade, and at the time of creation you will pass all the necessary dependencies through injection here, and then you will call the actual night mode or morning mode function activations. You need not to know about the inner implementation of these, so it will be very clean and consistent and it will hide all the complexity. So given that we have covered many of the design patterns, so let me put it all together here. What we have seen till now is the factory. We can create the factory based upon the type. So we can have all the instantiations of the devices by factory function. We can do the observer wiring by creating a motion sensor and adding observers to the motion sensor so that they can listen to the motion. And then we can use a facade. I have told you that facade, while creation we will pass all the devices to it and we'll have it as a clean object, and we can call the flow of the facade without taking care of any or paying any attention to the underlying subsystem. And then we have the routines. So imagine we have to create the commands, and we create the routines by adding a set of commands to that routine. So one of the commands can be related to camera, the other can be related to the temperature, the other one can be related to the lights, and then we simply build it. And this routine can also be called from any part of the system. So I think we have covered many of the design patterns in this example. So I will publish this code on GitHub repository and will put the details in the description of the video. Thank you.